Hello everyone, my name is Adeesha and welcome to Learn with Adeesha. In this video, we're going to be covering a quite elementary topic, the areas of polygons and shapes. Many of you are in the 7th, 8th or ninth grade and polygons and shapes are very much needed. If you're in a grade younger than that, such as grade 4, 5 or 6, you may also have heard of the term polygon and the term shape. Now, for those who need a reviser, a shape is basically the generalization for something that looks for something else. For example, a circle, a square, a pentagon, or a house-shaped pentagon in this case. These are all shapes. So, we will draw a small Venn diagram here. Alright? So this section is shapes. Now within shapes lies polygons. Polygons, as the name suggests, if you may have heard of low poly, which mainly uses triangles and other polygonal shapes which are just polygons for art, you may have noticed that the art seems a bit straight lined, as in usually the sides aren't curved at all. Usually they're straight, they're flat most of the time, and that's kind of one of the defining qualities of polygons. Polygons are shapes that are made with specifically straight lines. They have to be closed shapes, and they can be either convex, as in they have all of their diagonals inside like this, or they can be concave like this, where one diagonal, this one, is outside. There are also other shapes like stars, for example, with more diagonals that are outside. So you can know that more than one diagonal can stay outside of the main shape. But remember this, a polygon must always be closed. Never can a polygon be this or this. These are not polygons. But this, this and this, these two are polygons, if you ignore the bad drawings. But still, those are polygons. They're closed shapes made with only straight lines. An important distinction to know is that a circle is not a polygon. You may think, but Adeesha, a circle is a polygon because it's made of multiple tiny sides. No, that is untrue. A polygon is made of multiple sides, and you could say a very large polygon with a large number of sides is equal to a circle, yes. But a circle would have an infinite number of sides, and infinity is not a number. We will talk about infinity more in calculus or pre-calculus. Alright, so a circle is not a polygon because it has 0 straight sides. Also, the fact that a polygon must have defined and measurable angles. No matter what, there has to be an angle that you can measure with a protractor, even if it's not exact. It has to be measurable on a protractor, and it has to be roundable to a certain degree. So tell me, if we take a circle and zoom in on one side would mainly look like this. Can you tell me the angle? No, of course not. There are no angles in a circle, there are no sides in a circle, hence a circle is not a polygon even though it is a closed shape. Now within polygons are regular shapes, or regular polygons, which I will notate as R dot in the polygon section. So, regular polygons are basically polygons with the same side length, notated by lines. For example, 2 lines on two sides, for example, if I draw this line and this line, if we see the two lines, you can see that both of these have two lines. So if this has measure 5 centimeters, then this also has measure 5 centimeters. If two lines have the same number of perpendicular lines, meaning that the lines are on a 90-degree angle to each other, as in basically one corner of a square looking like this basically, then in that case, if they have the same number of perpendicular lines on each other, they are the same length. But what's also important to remember is that because of this, they also must have the same angles. So if this we can say is theta degrees, then this must also be theta degrees and this must also be theta degrees. Got it? Every angle and every side in a regular polygon is equal to each other. For example, side A would be equal to side B and side C, and angle A would be equal to angle B and angle C. Pretty simple, isn't it? Now then, moving on to the areas. Now what do we mean by area? Area is kind of a broad concept. It's like the area of a square, the area of a circle, or maybe just, how do you say this, the area that someone owns. You get it? So basically, area means the amount of space a shape occupies in a grid or in the real world space. Now usually we would measure area in square units. For example, you know the units of measurement such as centimeters, millimeters, meters, and kilometers. Scientists may also recognize micrometers. So all of these are measures of distance, length, if you had to say. Now, you can square these units to get centimeters squared, millimeters squared, meters squared, kilometers squared, and micrometers squared. These square units are used for area. The cube units though are used for volume. And you wonder where you get the square unit from? Well, obviously, it's one of the most basic shapes of all time. So, moving ahead, take a look at this bookshelf over here. You can see that all the sides are of the same length. Like this is the same length as this is the same length as this is the same length as this. Alright? So if you divide this into a whole grid, you can see that each section of the grid, each line of the grid, has the exact same length. So, this is where we get the square from, aka a simple square. Right? That's actually pretty easy. Now, if we take this side as A, since I just showed that a square is basically a quadrilateral, meaning a polygon with 4 sides exactly, with all angles equal to 90 degrees and all sides being equal, then we know that since both of these sides are equal, or in fact all 4 of them, we can know that all of these sides are A. If this measure is A centimeters, then all of these sides are A centimeters as well. Mind you, they cannot be written in different units. For example, if you write this in A centimeters, then this cannot be A meters. It has to be A centimeters specifically. So, now, what's the area of a square? Can someone in the audience right there tell me? Even if I can't hear you, can someone tell me? Well, basically the area of a square is as follows. Think of how you used to do multiplication, right? Now, if you wanted to do 3 times 7, manually, you would have to draw 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7 squares. So it's a 3 by 7 grid. So now you have to count the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So you would know that 3 times 7 is equal to 21. Pretty simple, right? Now, what you have to do is, if this were a square, all you need to do is take this as the first number, which we will call A, and this is the second number, which we'll call B. But in this case, in a square, both sides are A. Now, using the same multiplication method, we just need to solve for the product of these two, which is what happens when we multiply them. So then we get A times A is equal to the area, which will denote in large A, capital A, uppercase A, big A, you might call it. Or, in other words, you can write A times A as A squared is equal to the area. Now, just for a bit of revision, does anyone in the audience know what a square number is? I'm sure you know, but if you've forgotten or if you don't know, let me explain. Because if you're in a younger grade, this will come in handy later. Trust me, I know it's gonna be hard, but trust me, I will explain it in a way that you can understand. So a square number is just the same number multiplied by itself. Yeah, it's not that hard. So if we take 5 squared would just be 5 times 5. Now, this may be a bit hard for all you 4th to 7th graders, but you don't have to do this just yet. But what you have to do is memorize the first 10 square numbers, which I'll write. 1 squared is 1, because 1 times 1 is 1. 2 squared is 4, because 2 times 2 is 4. 3 squared is 9, and then so on until you reach 10 squared. In this case, the sequence goes 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. These are all the first 10 square numbers, and it's recommended to memorize all of these. Alright, now moving on to the next quadrilateral on our list, the rectangle. The rectangle is a square, but it's not the same. It doesn't have even sides, but 2 of its sides are one length and the other 2 are of another length. So we'll just use the same method as the square, and we'll call this A and we'll call this B. Of course, we can't call this A and this also A because they're not the same length. So what you're supposed to do is take length A and multiply it by length B, and then you get the area. Pretty simple, isn't it? So next up, our final quadrilateral on the list, which is a trapezium. Now this is a bit complicated, but in due time you will memorize it. And also, by the way, for those people taking IGCSE, Edexcel out there, don't worry, it's gonna be on your formula sheet. You don't have to memorize the formula for a trapezium. You do though have to memorize the formula for everything else, unfortunately. So, a trapezium basically is structured like this, or any way like this. It only has 2 parallel sides, which are denoted by these arrows. Parallel means that they flow in the same direction from left to right, or have the same gradient, you could say. And their distance from each other will not change. Now we will call this variable, this height, as, of course, height. H. We'll use the initial of height. So, H. We have that. Now let's take the first parallel side as A and the second as B. Now you're wondering, Adeesha, how do we do this for this? Well, you would take this as height, this as A, and this as B. It doesn't matter which one is A or which one is B. It doesn't have to be that the longer one is A or the shorter one is B. Because the formula goes like this. Take the height, multiply it by the sum of A and B, and divide the whole thing by 2. That's all. Take the height, multiply it by the sum of A and B, and divide it by 2. A and B must be the parallel sides, and H must be the height or greatest height between the parallel sides A and B. Got that? So, now that all that is done, we've just got 2 more things to cover. The area of a circle and the area of a triangle, which is going to be pretty easy. So, the area of a circle, now you need to know a few things about a circle. First of all, the center is, of course, called the center. Second of all, the distance from the circle's center to the outside of the circle, the outer lining, which we would call the circumference, say it with me, circumference, is known as the radius, also called r. And third of all, if you divide the circumference, which we will call c, by double the radius, which is also known as the diameter, but we'll get into that into circle theorems and how circles work, you get a special constant known as pi. Now, pi is an irrational number. It cannot be denoted as a simple fraction, of course. So, pi is usually written out as 3.141592. But for your sake, boom, you do not need to memorize the rest of the digits. Just memorize 3.14. 3.14. Very simple, isn't it? So now that you know all this, let's move on to the area of a circle. So moving on to the area of a circle. The area of a circle is defined as the constant pi, which again you will write as 3.14. And most exams will give you the version of pi that you're supposed to use. So 3.14 times the radius squared. As I told you before, squared just means times itself. So this would just be equal to pi times the radius, again times the radius. Pretty simple, isn't it? Yeah. Now then, last but not least, let's move on to a triangle. Now, a triangle, as you may have heard, is one of the biggest shapes in architecture and is used nearly everywhere, from computers to architecture again, to even such mundane things as movie making. Triangles are used everywhere. If you've been on a bridge, you've probably seen the structures that hold it up are made of triangles, and also because they are aesthetically pleasant. In simple terms, they look good. So, now, what's the area of a triangle? Now, there are 2 types of triangles that you have to know of. Right triangles, which I've covered in my trigonometry video, which have a right angle as one of their angles, and non-right triangles. There are more types of non-right triangles, but I will send you a sheet regarding those in the community post very, very soon. So, non-right triangles come in many formats. Scalene, let me think. equilateral, etc., etc. So, you have a non-right triangle and a right triangle, and both of these use different formulas, unfortunately. Sad, ain't it? So, anyhow, for a right triangle, you would use the formula half times A times B. Because a right triangle is just half of a rectangle. Pretty simple, right? And as with a rectangle, you would take this side as B and this side as A. You can do it any way around because the product will still be the same, obviously. And now, as for a non-right triangle, you would use the formula half times A times B times sine of C. You don't have to worry about this from grade 7 till grade 9. You will not have to worry about that because this is quite an advanced formula. In case you cannot see, let me write it for you much clearer. 1 over 2 times side A, which we'll say as this, times side B, which we will say as this, times sine of C. You will need a calculator to use this formula. So if you don't have a calculator, don't use this formula. That is the very simplest thing I can do. If you do not have a calculator at hand, no, a tablet does not count as a calculator. No, a phone does not count as a calculator. Don't use this formula. Now, you may be wondering, how do we define C, the angle C in sine C? How do we define C? Well, we'll define C as the angle squished in between A and B. Ain't that simple, folks? Now then, we are completely done with the areas of polygons and shapes. Now for a brief recap, because this video has gotten far too long and I know you have been waiting for this end session. So, to recap, shapes are things that look like something else. Polygons are shapes with only straight lines that are closed and can be convex, meaning that they have all of their diagonals or connections between vertices internally or inside the shape, or concave, meaning that they have it externally. At least one of their connections must be external. And then we have regular polygons, in which all sides are the same, like this, in which all sides are the same and all angles are the same. So, recapping areas. For a square, you would say this is A, because both of these sides are equal in a square, all sides are equal. So this side is A, this side is A, so the area would be A squared, or A times A. In a rectangle, you would mention this side as B, this side as A, and the area would be B times A, or A times B, or AB. However you like it, this is how you will write the area of a rectangle. For a trapezium, so for a trapezium, the area formula for that is you would define both of the parallel sides as A and B. It doesn't matter which one you label A and B, as with all shapes. And this side, which is the height or distance between A and B, which is a constant at all times, we'll name that H. So A in this case would be 1 over 2 times height times A plus B. You can see it right here. Now then, moving on to circles, which are quite simple actually. So, circles have a center, which is usually denoted as O, and a distance from the center to the outside of the circle, which is called the circumference, known as the radius. In this case, the area of a circle would be pi, the constant 3.14159.265, which I memorized, but you can just use 3.14, that's all you need to learn, r squared, or pi times r, or 3.14 times r, or any other variation of this formula, just so long as it has 3.14 or pi and the two r's, or r squared. And last but not least, moving on to triangles, which I've already covered in my sine, cosine, tan ratio video of trigonometry, but we'll do it again. So triangles come in two types: right triangles, which have one angle that is 90 degrees, exactly 90 degrees, denoted like this, or anything that looks like this. Anything that looks like one portion of a square. Now a right triangle's area would be A is equal to, or area is equal to, 1/2 times side A times side B. Mind you, both of side A and side B cannot be the hypotenuse. The hypotenuse is the longest side of a right triangle. So this side has to be A, or this side has to be B, or vice versa. This cannot be either, because this is C, as the Pythagorean theorem states. And last but not least, we have non-right triangles, where you can mark any of these sides as A or B to your liking, and the angle squished between them is C. For example, if I mark this side as A and this side as B, this side over here would be C. Very simple. And let's say if I mark this side is A and this side is B, then this angle would be C. So in this case, this is only for grade 9 only. You don't have to worry about this if you're below grade 9, but in this case, the area is equal to 1/2 times A times B times the sine value of the angle C. Mind you, to work properly, this angle C must always be measured in degrees and not radians. Check that your calculator is set to the correct value by checking your settings. Alright, so that is all for this lesson. We have covered every single polygon, what it means to be a polygon, what it means to be a shape, what it means for a regular polygon to be a regular polygon, and the area of, say it with me, a square, which is similar to multiplication, a rectangle, which is similar to a square, a trapezium, which you can see here is quite similar to the area of a triangle in some ways but not others, the area of a circle, which has radii and pi, of course, which you will have to learn about much later in your school life if you're only in like grade 4, and the areas of a triangle, including one that is grade 9 exclusive. So that is all for this video. I hope to see you soon, and I will see you in the next one. So goodbye for now, and that's all for me.